Enzymes, Matter and Energy Unit, Video 6. Models of the enzyme. An earlier version of the enzyme model portrayed the enzyme as a key and the substrate as a lock. This model has since been replaced by the induced fit model. The induced fit model, which suggested that the shape of the active site is slightly altered when the substrate molecules are trapped. This makes the fit between substrate and enzyme tighter to further speed up the reaction. The active site is a location on the enzyme where it bonds to the substrate to speed up the reaction. So we have our substrate and we have our enzyme and we have the active site. It just slightly moves to fit, then it changes the bonds, and then the products are released. So the enzyme never changes, just your substrate is different from your products. Factors that affect enzyme reactions. A single enzyme may catalyze from 100 to 30 million reactions every minute. Various factors affect how fast an enzyme can work. In the human body, enzymes function best at 37 degrees Celsius, which is our normal body temperature. Reactions occur more slowly at lower temperature, and they do not occur at all at very high temperatures. At high temperatures, the protein changes shape. So therefore, it doesn't fit into the substrate. Any change in shape of the active site of an enzyme will severely affect the enzyme activity. High temperatures brought on by fevers can be dangerous to human health for this reason. Your body cannot function, and that's why people can die of fevers if you can't get the body temperature regulated. Homotherms, these are animals that maintain a constant body temperature, are able to keep the enzymes at their best temperature. Enzymes also function best within certain pHs. pH refers to the acidity of the environment. Pepsin, an enzyme that breaks down proteins, functions best in an acid environment and is found in our stomach. Tripepsin functions best in a basic environment, is found in the small intestine where the pH is 9. Acid or basic environments affect hydrogen bonds, which in turn affects the folds of the active site. Therefore, the shape of the active site and the function of the protein is adversely affected. Enzyme activity is affected by the concentration of the substrate. As the number of substrate molecules increases, the number of collision increases, and the rate of reaction increases. Once the number of substrate molecules exceeds the number of enzyme molecules, the reaction can't proceed any faster. So therefore, the rate levels off. So basically, you ran out of substrate molecules. And the enzyme, there's no substrate to react with the enzyme, so therefore you can't go any faster than you are. Competitive inhibitors are molecules that have shapes similar to the substrate. They bond with the enzyme, and the enzyme is unable to catalyze the reaction with the correct substrate. So, and hence, they would slow down a reaction. The production of chemicals is regulated by another site on the enzyme, known as your regulatory site. Reactants or product molecules can bond with the regulatory site with very different results. When there is an excess reactant present, the reactant bonds with the regulatory site and improves the enzyme substrate fit, and the reaction is catalyzed. And this is known as a precursor activity. So this is when there's excess reactant. When there is excess product present, the product bonds with the regulatory site, and this prevents the enzyme from attaching to the substrate, and the reaction stops. This is known as feedback inhibition. Precursor activity and feedback inhibition are collectively called allosteric activity.